Watch how this giant lens harnesses the power of the sun. This lens bends sunlight that hits it down to a point. It does this through these concentric lines. As the light hits it, it refracts, goes down to a point. All the light hitting this lens is over 1,000 watts, which is a lot of energy, and it concentrates it down to a point. That's how I can melt copper, melt rocks. This fog demonstrates how this Fresnel lens channels the sunlight to a focal point. Watch what it does to a rock.
What I have here is a Geiger counter, and every click means that it's detecting radiation. The clicks now aren't very scary though, because it's normal for there to be a small amount of background radiation. What isn't normal is this little box. Whatever's in here is extremely radioactive, and it's worse than when I tested nearly pure uranium. But anyway, now to open it up. Inside, it doesn't actually look very scary, and it's just some small pieces of metal in an old plastic container. Now to open this container and see what it is, and it's just a bunch of old watch dials. At first, it might seem a bit weird that these would be so radioactive, but these aren't just any old watch dials. They've all been covered with a paint containing radium, which is an extremely radioactive element. What's interesting is that if I blast them with UV light, they fluoresce green, but this has nothing to do with radiation. It's actually just from something called a phosphor, and this one's made from zinc sulfide. This is the same zinc sulfide that's commonly used to make glow toys, but when it's mixed with radium, it's able to glow on its own for years without ever having to charge it up. These were all made in the early or mid-1900s, before they cared about how dangerous it was. Unfortunately, though, over all this time, a lot of the zinc sulfide has degraded, and they're not able to glow on their own anymore. However, they're still extremely radioactive, and they have to be handled really carefully.
This might be the most gorgeous butterfly you've never heard of. It is known as the green dragon-tailed butterfly, and these guys are stunning with vibrant colors and a unique flight pattern that still baffles researchers to this day. Unfortunately, these beautiful creatures only look and live this long for about 7 to 12 days. It really shows the most beautiful things in life are fleeting.
This is a CMY cube, and it's not blue. And it's not magenta. And it's not yellow. It's actually everything. So next time you're having an argument with someone, remember, you could be talking about the same thing, just from a different perspective.
Let's try something new today. Normally, I just dip things to get a nice solid color, but today we're going to try sponge anodizing. By hooking the black side up to a sponge, instead of the steel bowl, I've essentially electrified the sponge. The idea is when you hold the sponge onto the niobium, that it will change to the highest voltage color you've set. In this case, purple. If I hold it on for shorter times, it doesn't quite reach the purple. But if I hold it on for a longer time, then that's all we get is purple, purple, purple. This is looking quite pretty, actually. See, if I go a little bit faster, then we only get the blues, which are a low voltage color. But I think I want to add some higher voltage colors, so let's crank it up so we get some nice greens and teals in there. Oh, that's quite lovely. All the greens, all the teals. Oh, that is a nice bright variety of colors. Rinse the baking soda off, and we've got this beautiful vivid palette. Perfect.
This is another tour of a fish's mouth. Immaculate condition, do not sleep on this one. Today we're probing a manduba. It's an odd looking catfish. As we enter, look to the left. We'll see some spiky teeth on the fish's gills. These, as we know, are not actually teeth. They're also on the right. These spikes are gill rakers. They catch small food particles for the fish to eat. In the middle, something new. See those two bulbous things? Those are patches of extra teeth that the catfish uses to get a firm grip on slippery meals. And of course, under the extra teeth is an entrance to the fish's esophagus. Let's get in there.
A great challenge for you that will test your critical thinking skills. You're going to need an apple juice jug. I drilled a hole in the lid, 2 holes, and with some hot glue, glued in the 2 straws. The yellow balloon is hooked to the blue straw. So if I want to blow up the balloon, blow in the blue straw, nothing happens with the red straw. Now, put everything in the bottle, and then you challenge somebody to figure out how this works. All right, so you're just going to have to bend it in place, twist it. All right, if I blow on the blue straw, the air in the bottle will escape through the red straw, and the balloon blows up. No problem at all. But what happens if you blow on the red straw? The balloon still blows up. How in the world can you blow up the balloon? By blowing on the red straw. Comments below. I'll tell you in the next video.
This is 56-year-old jet fuel, and it feels like silly putty now, but still reeks of regular jet fuel. I found it today while digging up a crashed jet that I found in the woods. The stuff is also seemingly impossible to get off your hands, and this is what it looked like after 10 straight minutes of washing. I guess I'm just gonna have to be left-handed now.
I always thought that popcorn was made from corn like this, but it turns out I was totally wrong. Normal sweet corn is way too soft, even when it's fully dried, and it isn't able to pop. To make popcorn, the kernels need to have much stronger shells, and a completely different type of corn is used. The kernels on this one are way harder, and they kind of feel like uncooked noodles. To pop it, it's apparently exactly the same as regular popcorn, and I can put it in a microwave. I'll put it in for 2.5 minutes, and now I just have to wait. Okay, so now I have a bunch of nice and fresh popcorn. It's pretty good.